it. Once again, congratulations. My name's Addison. I oversee competitions at Kaggle. I want to welcome you to the first winners call for the HuBMAP competition. I will fade to the background for the majority of this call. This is primarily between you, our winners, and the HuBMAP team. The way this will generally work is I will hand things over to Kati to present or sort of introduce herself and the team. We'll then give it to you to show your presentation, walk us through, and then the HuBMAP team may have some questions at the end. But before then, do you have any questions before we get started?
Okay, no problem.
Great. Well, Kati, would you mind kicking off the introductions for your team? And you are on mute.
Hi. Maybe I'm in here twice.
Yeah, I can see you in twice. There you go.
Yep. I think you need to unmute your second screen now somehow.
Can you hear me all right?
There we go. Great.
All right. Yeah, I'm not used to Meet. We do a lot of Zoom sessions. So Addison, Amy, thanks so much for hosting us all. Thanks for hosting the competition. This is a true collaborative effort between the Human Protein Atlas, and I see Trang here, and the HuBMAP team. And from our team, we have Abhirup and Yash, which have been doing the lion's share of all the organization of the data and also the algorithms together with the Human Protein Atlas team. And both congratulations to being the winner, one of the winners. We are very, very glad to meet you in person. And we hope to learn more about your work and hope that you will continue to come into our competitions. There are 2 more planned, right? So we did 2 so far, and there are 2 more competitions planned. So I will give it over to Yash. I think there is a slide deck planned, maybe. And then we would also love to hear more from you. So Yash, if you want to take it over or Trang.
Yeah, so hi, I'm Yash. I'm a research software developer here at IU. I work with Kati's group, and I'm involved with, setting up the competitions and sort of overseeing it. I believe the slide deck would be from Wolf, not from our side, presenting his solution. Yeah.
Hi, I'm Chang, and I guess I will be representing HPA today. I'm a PhD student and at MS Lab, which is the other PI in this competition. And yeah, congratulations, and looking forward to hearing more from you.
Amy or Brooke, you want to give a brief introduction?
Sure. Sorry. Hi, everyone. My name is Amy Kemper, and I'm part of the Google team. And we were, along with partnering with everyone to help make the competition happen. We also are part of the sponsorship money that you guys won. So congratulations, and we're excited to hear more from you today. So I'm not sure if Yash, you want to take it from here, or Kati?
Maybe our group wants to introduce himself.
Hi everyone. So my name is Abhirup, and I'm a research assistant here at CNS. So yeah, I've been taking the winner solutions of the Kaggle 2 competition and trying to fine tune it further on some internal data. Yeah.
Well, Opusen, we'll hand it over to you. Would you like to share your presentation and begin?
Okay, then I share my window.
great. We can see your screen.
Is it okay?
It's okay.
Okay. Then I'll start the Kaggle Winner presentation. This is first presentation for the competition HuBMAP HPA, Hacking the Human Body. I'm Yoshinori Kawamura, and my Kaggle ID is opusen. About the agenda, there are background, training methods, simple model, summary, and question and answer. Background. I have master's degree of food science, where it has nothing to do with programming or data science. I'm engaged in AI development, training, annotation, modeling, software development, and deployment. I have been using semantic segmentation for visual inspection for factories. I thought it would be great if my skill improves through this competition. I'm not very sure, but it costed about 200 hours. Training methods. I used Google Collaboratory Pro Plus. 100 and I used and both GPUs have 16 GB memory. P100 has slightly better memory than V100. I infrequently used A100, which has 40 GB memory, but not used for submission models. Training cost about 4.5 hours for SegFormer MIT-B4 in Tesla V100. Tools. I used segmentation for training tool. To use it as end-to-end tool, I customized data augmentation pipeline. With tools such as segmentation, you can easily replace the model or training configurations with others. It's one of the best ways in terms of sustainability and easiness, if the tool is useful enough. I decided to use segmentation through this competition because I wanted to consider this tool as a standard training tool for my job. Models. I used SegFormer MIT-B3, B4, and B5, but mainly I used MIT-B4. I tried MIT-B2, but MIT-B4 was much better. I guess other competitors had difficulty in training MIT-B4 or a bigger one because of limited resources. About transformer models, many participants tried to seek good transformer models in this competition, and SegFormer was one of the most popular models. I use this model because simply it is incorporated into segmentation and it worked well. There is swing transformer V1 in segmentation, but not good as others reported. Methods. I used batch size 1 with group normalization that enabled training of SegFormer MIT-B4. It was better than batch size 4 with batch normalization in both local validation and public score in a few tests. Two classes, background and FTU, I used because it was better in rank prediction, which is also reported in other participants. Other conditions are like this. Cross entropy and birth loss equal 1 to 3 steps. 45,000, and optimization is RMW. Data. I hand annotated rank images from scratch. Stain transfer with touch stain were used and added spring and rank external data with pseudo-labeling. Pseudo-label for HPU's prostate and large intestine were used. About stain augmentation, I used original HPA images and additional datasets stained with H&E or PASS. Total images are 1,755 images. Also, additionally created two stains datasets were used for single MIT-B5 model. External dataset. This is external datasets, both Lang and Spring are from single image and separated into 73 and 39 images respectively. I tried using kidney image from the previous HuBMAP competition, but not working. Data augmentation. Datasets image size are 2,000. Augmentation was used in segmentation augmentation pipeline. These resize and random crop are the original pipeline of segmentation. Resize and random crop. I sampled single SegFormer MIT-B3 to MIT-B4 and 3 MIT-B5 with different image sizes. I actually wanted to ensemble more various models. And it's like the combination of SegFormer and other transformers, or SegFormer and other CNN. But because there isn't much time, I started model ensembling 4 days before the end of the competition. So I simply ensembled only SegFormers. Different pre-trained models, seed, and additional stain datasets were used in some models. Average of sigmoid outputs were used for predictions. Training time, it depends on which GPU you use. In SegFormer MIT-B3, 9 hours for Tesla P100. And in SegFormer MIT-B4, 4.5 hours for Tesla P100. In SegFormer MIT-B5, 12 hours for Tesla P100. In inference, I used whole image and ignored pixel size. Test time augmentation is horizontal flip and different image scales. Thresholds for each organs are like this. Rank is relatively high. In a Kaggle notebook, about 2 minutes for single model inference. About from 80 to 90 minutes for ensemble inference. Simple model. Single model SegFormer MIT-B4 has the highest score of private 0.82821. Although SegFormer MIT-B5 was as good as MIT-B4 in the last phase of the competition, MIT-B4 consistently gave better results in any dataset and any augmentation in this competition. I think MIT-B4 is easy to use if you want to train a single model in this competition. this table shows the transition of private score. The left column is model I used. And the second row, second column means private score. This is public score, and public HuBMAP only score and private gain. This is baseline of MIT B4, which has a score of 0.62695. And this is private gain, set private gain as 0. This baseline model plus process downscale. In this competition, there are 160 sized image. So it is needed to prepare downscaled prostate image. This private gain is 0.057 and it's big. And battery size, this one plus battery size. This is private gain is 0.01. And I added argumentation, data augmentation, and pseudo label for prostate and intestine. The private gain is 0.024. And I added hand-labeled rank annotation here, and the private gain is really high, 0.072. Train bar. So I trained all train images here, and private gain was 0.048. And pseudo label for prostate and intestine. It's difficult to, it's very hard to create segmentation label for all images. So I created partial annotation and merged it with original segmentation label. And this is the boost is 0.001. And I added chain transfer by touch chain, and this is almost 0.01. And I added external dataset, rank and spring. And the boost was around 0.006. I added HPA original images, which is not stained, and the private gain was minus. So added HPA original dataset doesn't contribute to increased private score, although public score increased. And brightness, private gain was 0.008. Optimized threshold, private gain was 0.03. Added test time image size augmentation, multiplied by 0.8, 1, multiplied by 1, multiplied by 1.2. Boost was 0.0003. And I ensembled models from here, and private gain was like this. And I sorted the table by private gain. This is highest one, and this is lowest one. And added HPA original dataset, which were not stained, was worst. And the best contribution is rank annotation. This is 0.07. And next, prostate downscale and argumentation augmentation and pseudo label for prostate and intestine, better resize, stain transfer by touch stain, brightness, external lung, external spleen, or train images, and ensembles. So about SegFormer, why did this model work well? Although I don't have enough knowledge to review it, I came to think the lightweight or MLP decoder might help. Segmentation models are composed of two parts, encoder and decoder, and its decoder is called lightweight or MLP decoder. In this competition, adapting to domain shift is much more important than precise segmentation, so the performance of the encoder should be more important. The table shows the parameters of decoder. From bit B2 to bit B5, there are only 3.3 million parameters. If lightweight decoder is enough, a lighter decoder enables more powerful encoder in limited resources, which could lead to high scores. In the paper, it is written that large receptive field of transformer enables the use of lightweight or MLP decoder, and this decoder doesn't work well in CNN models. So if the lightweight decoder has advantage in limited resources, using combination of transformer and lightweight decoder could be better than CNN. Although I think SegFormer itself originally has high performance, these circumstances give it more advantage. Summary. I used end-to-end segmentation with customization and simply ensembled SegFormer models. Use of group normalization and batch size 1 make it possible to train SegFormer with B4 and 5 in limited resources. I use hand labeling from scratch and external datasets and pseudo labeling. And question and answer. As I said, I'm not as good at listening to English, so I'm using simultaneously interpretation on Google Meet. Do you have any questions?
Thank you. We will, for any questions, maybe Yash, we'll start with you. Since I know you've been looking at the data. If you have them, maybe ask them, but also type them in the chat just in case it's easier to read.
Mm-hmm. Yeah. So my question was, in the metadata, we also had the tissue thickness provided. So I was wondering, like, if you use the tissue thickness as well as part of your solution, or the pixel size.
I didn't use pixel size or tissue thickness because I thought enough augmentation covering them is enough. So I ignored that information.
And I was wondering, what was your highest scores that you got without using the external data?
without external data, well, in simple calculation, the boost of external spring was 0.00594 and the rank was 0.00622. So final score 0.83562 minus this score is 0.82346. But it's really simple calculation, and can you see my presentation slide?
Yeah. Yes.
Here, external one and external spring. Maybe this brightness, this is usually augmentation brightness was added in early stage, but I added here, so maybe this 0.0853 might contain the boost of this one. So this is simple calculation.
Right.
Is it okay?
Yeah. And I had one last question, which was on slide 18, you showed the thresholds that you set for all the organs. What was your reasoning behind setting those thresholds? Was it more experimentation?
The reason of threshold settings. I tested several threshold each organ and probed which is the best. In kidney, 0.5, I tested 0.5, 0.4, 0.3, 0.2, and 0.3 was the best. Large intestine, 0.2 was the best. Also in lung, I tested 0.4, 0.5, 0.6, and 0.7, and 0.6 was the best. I decided like this.
Okay. Yeah, thank you.
Hi. Hello. If you had more time, what further approaches would you have tried to improve the score?
If I had more time,
Yeah.
well, maybe ensembling, I would continue ensembling models. But after seeing other competitors' solutions. So it's a difficult question. Let me see. Hi.
Yep.
Maybe ensembling models. Yes.
Yeah, I just I'm asking because I'm trying to fine tune your networks. So that's the reason why. Yeah, so I'm trying to like improve upon them. So I was just wondering if you had time, maybe some approaches you would have tried to improve the score.
I'm forgetting the settings, and I can say that this mod, I don't know, it's because of this task or this model, but it's really sensitive to settings. If you change the size of image in some augmentation, the performance could be dropped. I suffer from its unstable one. For example, in prostate, the hyperparameter would be relatively suitable for the task. I tried another settings, but turned out to be bad.
Okay.
Okay.
I have several questions that I also type in the chat, if that's easier. But the first question is, did you also use DICE for local validation? And do you think it's the best metric given the setting of this competition?
Well, I used MDICE metrics in my local validation, but I didn't trust my local validation. So actually, I didn't see this information. So I submit a lot of models as possible. So I actually didn't compare which metrics is best, MIOU is best or MDICE is best. I'm not, I didn't think so much about it.
Yeah, thanks. And then I have another question about have you looked at, or what do you think is the best or worst performance based on tissue type?
Worst performance in tissue type? Of course, lung. It's very difficult to annotate lung alveoli. I guess it's even for professional, it's very difficult to define the task of segmentation. The lungs serves a three-dimensional structure, and very difficult to define which is alveoli and which is the conduct and the just spaces. So lung was most difficult task.
And what was the easiest?
Easiest? Maybe large intestine. Kidney. It's kidney is also easy, but when I added the dataset of previous HuBMAP competition, the score clearly dropped. So I think my model can predict the private dataset correctly, but not sure the kidney. Not sure kidney from other datasets. So maybe large intestine.
And I see that Katie has a question before she left. That what do you think would make future Kaggle competitions easier?
Future competition easier?
Mm-hmm.
It's a difficult question.
What was the most difficult things in this competition?
Domain adaptation.
Can you elaborate more on that?
So yes, it's maybe we can't trust local validation in this competition. So many players submit their modules as much as possible and didn't trust their local validation. And there are limitations of submission of modules in Kaggle. So if it became more easy to validate in local, that would be much easier to yes, tackle.
Mm.
Does my answer make sense?
Yeah, no, I think a good validation, local validation strategy will always help developing better models. Yeah.
Okay.
I think the main thing is that we don't have so much annotation. Like the annotation is expensive.
Annotation is expensive?
Yeah, to generate correctly for many different tissues.
I can imagine preparing a lot of annotation in various tissue would be very expensive. Especially, it's difficult to unify the criterion of annotation.
Yash and Aviru, I don't know how much you have analyzed the winning model, but I think it's interesting to see if the current model can predict different tissue type that have kind of similar shape of the FTUs to see the generalization.
Yeah, actually, I am kind of trying to work towards that. Like, how can these solutions be generalized better? Like, that's why I was asking, like, asking opusen what he could have tried, because in some instances, the models do not generalize that well. In my observation, so I was trying to test the model on some internal HuBMAP data, and the predictions were not as good as the one in the competition. So yeah, so yeah, how I was just thinking, like, how do we make these models better? Like, how do we address the problem of this domain adaptation better? Right. So, Opson, do you have any more, like, what would you further try to help with the domain adaptation issues, or how to generalize the models better? Because I'm pretty sure, like, yeah, as you said, the models are like kind of unstable. Like, if you change even the resizing, you draw your model drops, right? So if you change the whole, like, data itself, so then the performance may not be as good. So any further approach to try to help the model generalize better would be helpful.
Sorry.
Would it help to type the question?
Yeah, essentially, like, yeah, how to address the domain shift problem according to you.
How do you address the domain shift problem? I think in this segmentation task, the performance of encoder might be important. So modeling like unit might be heavy. So I think SegFormer is good options to tackle with shift program because it has less parameters. It seems have less parameters than other models. I didn't try Coordinate. I didn't research that model so much, and maybe it's incorporated into decoder like unit. So maybe incorporation into unit could be heavy if you have enough computational resources. It might work, but if there is limited resources, it's difficult to use one. And,
you said okay. You said you tried like multiple stains, right? So did you try like mapping all of the data sets into one stain? Like, is mapping all the data sets into one stain more beneficial, or having just different kinds of stains in the whole data set? Like, which of the two would be better? Did you try like mapping everything to a single stain?
single stain?
You said you tried 4 or 5 stains from dot stain.
Yes, I used 4 stains.
Yeah, my question is like, have you tried like mapping all of the data sets to a single stain so that the whole data is of one stain during training?
One stain. I didn't try stain transfer.
Yeah, stain transfer.
So much. I originally used a lot of color augmentation, so I wasn't sure stain augmentation helps so much. So I simply added many various separated data sets.
Okay.
So this data set is really huge, so I don't think it's a good way to make many data sets. But if you have customized code or good computation resources, you can train with one dataset.
Also, anything to consider or any advice when we are trying to like train your models on a new data set that's not in the competition?
Well,
Any like implementation details that usually are missed out?
I guess default settings work enough, but in public in GitHub repo it is said it's unstable and suffer from difference of seed, but I didn't feel such unstable behavior. I'm not sure other datasets though.
Okay.
Abhirup, do you have any other questions you might have seen when you were like validating the code?
Yeah. So I just had some like just code wise, so like just so that I get it right. So you just are you I was looking at your code, and essentially you assign like you convert the masks from the array, you generate the masks, but you assign a different number to each class, right? With the large intestine the number 2, and I think spleen was number 5, and so on. And is that right? So the mapping from the different organs to the class. So if I'm like, let's say, training on like an external like large intestine data set, I would have to just look at your mapping and then create my masks that way. And in general, can you share your mask generation code as well? I do not find it in the code that you shared.
I can share it later.
Yeah, that would be helpful for me if I can just take a look at that.
Code for creating class from class 0 to class 6 1.
Could you repeat that?
Code for generating multiple
Class masks.
class
Yeah.
mask. Okay. Hi.
Yeah.
If I came up with other information about fine tuning or tips for improving performance, I'll share.
Definitely. Yeah. That's it for me.
Were there any questions in the chat that were not covered?
I think we covered all the questions in the chat. I had a final question related to the ensembling. When you use like 6 models in your ensemble, how do you then merge the predictions to generate the final predictions?
I customized it I see segmentation repo in GitHub saying it published module ensembling functions. So it might work at the moment, but in this competition, there weren't such functions. So I changed some codes. Well, just a moment. I'll share my how can I change my display?
There should be a button at the bottom with the square and the arrow.
Okay. And again, is it okay?
I can't see it yet.
Can't. Share your entire screen. Who wants to share the content of your screen with me to google.com? I can't push share.
It's a little odd.
Then, okay. Can you see now? Oh,
Yes, we can.
okay. This is my public notebook. How to set これは in segmentation's code, it only originally it only outputs argmax information like class 0, class 1, class 2. So I modified the code like this and added settings of sigmoid output and where I can't open. It's maybe train inference pi. Maybe inference pi. It's difficult to open here, but it's not good implementation. In low sigmoid outputs, there are class 0 background and class 1 FTUs. And it's the dimension of the tensor is width and height, and channel is 2. And I used only channel 1 for FTU. I ignored channel 0 for background. And I got simple average of the class 1. Yes, so it's not good implementation. So I use it like this.
Okay, thank you.
So I think we are a little bit over time. Opusen, we had accidentally scheduled this for an hour and a half, but it should have been, I believe, just an hour. I want to see finally, do you have any questions for us?
I'm okay.
Well, great. Once again, congratulations. Great work. We have 2 more calls that will happen next week. Once those conclude, we will distribute your prize funds, and we hope to see you again in future competitions.
I really enjoyed this competition, and I'm looking forward to the next one.
Great, thank you so much.
Thank you so much.
HuBMAP team, I think we're sticking around for a little bit after this to discuss the next one. Opusen, thanks for your time. I'll end the recording now.